Hello, this is the next video in a playlist that I'm calling Correlation, and we're going to look at partial correlation and its relationship with multiple linear regression. So as a reminder, the partial correlation between x and y. So it's essentially the correlation between x and y while controlling for the variables in z. And this is a vector. It measures the correlation between x and y while controlling the variables in z. And from part one in this little mini series within the playlist of correlation, we determined that the partial correlation can be written like this, where e of x and e of y are residuals from regressing onto z. So what this is, we want to find the correlation between x and y. So while trying to control for the effects of z. So what we do is we take x, regress it onto z, find the residual. So that's the essence of x, but with the effects of z removed. And then we do the same thing for y. We regress y onto z and then take the residual. So that's y minus predictive values for y. And that is the information in y with the effects of z removed. And then we find just the zero order correlation for this. But I'm going to pass you off to part one in this partial correlation series for that. Now in multiple regression, this is the setting that we regress y onto this set of regressors. So x and then all the z's. Now if we take this beta and put it in with the z's, so called z0, 1, those can be summed up in matrix notation like this, and this comes down. Now ultimately, remember, we're interested in the relationship between x and y. And so in multiple linear regression, we might test a p-value for beta 1 to see if it's significant. And if it is, then we say that x is significantly associated with y. And then, of course, I forgot to add this, when I first did this video, while controlling for z, for these other variables. So x is related to y, or associated with y, significantly after controlling for these variables z. And that's kind of how you interpret that. And to me, it has a similar flavor as this partial correlation. Now, the way we'd interpret beta 1 hat, or even beta, it's for every unit increase in x, the mean y increases by beta 1 amount while controlling for the other variable z. But please note, this is not correlation. It's just measuring the effects of x onto the average y. So it's not correlation, but somehow to me it seems like they're related somehow. So how are beta 1 and the partial correlation related? And that's what we're going to look at on part 2. Now, as a reminder, the partial correlation is calculated with these residuals, EY and EX. And so this is, remember, it's essentially the information in Y where the effects of Z have been removed. And the same thing here, it's the essence of X with the effects of Z removed. Now let's just do an ordinary simple linear regression of Y onto X, and that's this equation. Now the least squares estimate for gamma would be this. Now it's, the cross product of x and y divided by, some sort of variance associated with x. And I'm going to pass you off to a video which you'll see down below. But this is the least squares estimate for gamma of 1. Now let's look at the relationship between gamma hat and the partial correlation. Now the partial correlation was this by definition. So let's multiply it by 1. This quantity divided by this quantity. And we do that because then this is the partial correlation that we saw. I'm sorry, it's the least squares estimate for gamma, right? And then times this constant. And we kind of know that, like in just ordinary simple linear regression, that the slope parameter is associated with the Pearson's correlation, or the zero correlation between x and y. And we know that since this is positive, because these are, it's the sum of squared things, the principal root, And this is positive. So the sign, so if partial correlation is negative, then the slope parameter is negative. I think that's pretty common knowledge. But how does that relate to that multiple linear regression equation? Well, from video, multiple linear regression, partial residual plots, and that's the video I passed you off to see the least squares estimate for this, we proved that this simple linear regression of the residuals and then calculating the least squares estimate for the slope parameter is 100% equivalent to that slope parameter that we looked at right here. The least squares estimate for beta 1 is 100% equal to the regression of these residuals onto each other. Right? So now that tells us that the partial correlation between x and y given z, or controlling for z, is actually beta 1 hat times this constant. So they are related. I mean, it always, it just feels like they should be. Well, mathematically, they are. And since this is always positive, the sign of the partial correlation, so whether it's positive or negative, is 100% equal to the sign of beta 1. So if this is negative, that has to be negative. If this is positive, that has to be positive. They have the same sign. And beta 1 hat is proportional to the partial correlation coefficient, right? It's just a constant multiple of it. And so that's the relationship between multiple linear regression, looking at a beta coefficient and actually calculating the partial correlation between x and y controlling for the z's. All right, well, that's all I have for this video. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.